Hello and welcome to helpyourmath.com. In this video, we're going to look at the graphs of transformed sine and cosine functions, and we're looking at all the transformations here. I will assume that you know the basics about sine and cosine functions, but I will review the parent functions briefly. If you need to, stop this video, go and watch the one where I don't have C and D, or go back and watch the parent function video. Review of our parent functions. So the parent functions are given by f of x equals sine x or f of x equals cosine of x. The domain for either sine or cosine is all real numbers. The range is from -1 to 1. The amplitude of sine or cosine parent function is 1. The period is 2 pi. So that's sine and cosine functions are periodic, meaning it takes one full cycle of the parent function is 2 pi. And then it's going to repeat, right? So for sine graph starts in the middle, it goes up to the top, back to the middle, down to the bottom, back to the middle. That's one complete cycle. That's one complete period. It went all the way up to the top and down to the bottom. For cosine, we start up at the top, we go down to the middle, down to the bottom, up to the top. And that would be one complete period of cosine. There are 5 key points on our parent function graphs, and they're given by these 5 ordered pairs. So for sine, like I said, we start in the middle at 0, goes up to the max at 1, back to the middle at 0, the bottom at -1, the minimum, back to the middle. Cosine, we start at the top, go to the middle, go to the bottom, middle, top. The x values are determined by the period, right? So we figure out the increments of the x values by taking the period and dividing it by 4. Okay, let's just talk about transformations of sine and cosine graphs. Some of this will be review, some of this might be new. We're talking about everything happening. So we have something being multiplied to the function, then we have something being multiplied to x, maybe something being subtracted, and then something being added behind it, the function itself, which would be that vertical change. Okay, when we look at one thing we're interested with sine and cosine graphs is the amplitude, capital letter A. Capital letter A amplitude is given by the absolute value of A. The sign of A is important though, because if it's positive, then it goes to the maximum first. So if we're talking about a sine graph, it goes middle to top. If we're talking about a cosine graph, that just means we start at the top. If A is negative, however, the graph goes to the minimum first. So sine would start in the middle, go down to the bottom. Cosine would start at the bottom. We care about the B in these because that helps us identify the period. So while the period is not just equal to B, it couldn't be that simple. It's actually part of a little equation. We would figure out the period of the function by taking 2 pi and dividing it by that B value. The graph will shift C units to the left if C is less than 0, or to the right if C is greater than 0. So C is a horizontal or vertical, it's a horizontal change. And when we're talking about sine and cosine graphs, we call it a phase shift. And it's a little bit wonky here, but the phase shift, the starting value now for the x's, right? So sine should start at 0, and actually cosine should too. When we have a phase shift, it's going to move C over B units. That's the horizontal shift. And the reason for that is because what we're looking at is bx minus c is equal to 0, and that would be bx equals c, thus x equals c over b. So rather than starting at 0, the graph will start at c over b. And the complete period, so one complete period, the x coordinates, will be c over b plus c over b plus the period, right? So it's the starting value plus however long it takes to complete one cycle. So that would tell us the x coordinates for one full period. And then also if there is a d value, if there's something being added, that would move the graph up or down depending on whether d is positive or negative. It also affects the midline. So something, especially when there is that vertical shift, we want to look at the midline. That's like where it hits every other key point is that midline point, right? So usually it's 0. That's given by y equals d. Okay, let's look at some examples, and we're going to go through this one nice and slow, and we have quite a few examples. So sorry the video is so long, but I want to make sure that you have a firm understanding of these because I know they can be scary. All right, what do we have here? We have A is -2, B is 3, C doesn't exist, so it's 0, and D is -1. How do I know that that -1 is D and not the opposite of C? because it's not in parentheses. If I wanted it to be the C, I would have had to have put it in parentheses. It wasn't given in parentheses, so it's a vertical shift. Okay, let's fill in information that we know based on these values. The amplitude is going to be the absolute value of negative. Sorry, that looks like a 3 to me. Can't read my own handwriting. Maybe I did write -3 by mistake. There we go, -2. The absolute value of -2 is 2. The period, we figure out the period by doing 2 pi over b, so it's going to be 2 pi over 3. The phase shift, remember what this is? This is c over b. Well, since c is 0, there is no phase shift, or it's not shifting at all. It's just starting at 0, which is great. The equation of the midline, so this is given by y equals d. In this case, it's y equals -1. So we care about that. Usually I represent that with a dashed line. We'll get to that after we look at the, well, we'll go ahead and draw that in. So -1, so that means every other point should be hitting at -1. And that's going to come in handy as we're filling in our key points. So we have x and y. And what else do we know? So there's one thing I didn't have a thing for, but it's good to know, is that a is negative. And so since a is negative, we are starting at the bottom. Before we get to that, let's fill in our x values. So x is starting at 0, and now we want to figure out the increments. The increments will be given by, do you remember how to find the increments? Take the period was 2 pi over 3, and divide it by 4. So our increments are going to be 2 pi over 3 divided by 4. This is 2 pi over 3 times 1/4. Dividing by 4 is equivalent to multiplying by 1/4. That's 2, that's 1. We end up with pi over 6. So our increments are pi over 6's. We're going to add pi over 6. 0 plus pi over 6 is pi over 6. Pi over 6 plus pi over 6, that's 2 pi over 12, which I'm going to simplify. I'm sorry. 2 pi, I'm adding everything here. 2 pi over 6, which I'm going to simplify down to pi over 3. Then it's going to be pi over 3 plus pi over 6. I'll use my unsimplified version. So 2 pi over 6 plus pi over 6 is 3 pi over 6, which is pi over 2. And then I'm going to use the unsimplified because I'm adding another pi over 6. That's going to be 4 pi over 6, which is 2 pi over 3. Is that what I was expecting for that end? Yes, it matches the period, so I feel really good about that. Now for the y's. Okay, so y, we're starting at the bottom. We're starting at the minimum value. The amplitude is 2, so we are starting 2 units below the midline. The midline is at -1. What is 2 units below -1? Count with me. -1, -2, -3. So we are starting down at -3, 2 units below the midline. Then we go to the midline. Now we're going to go 2 units above the midline. That's -1 plus 2 is 1. Go back to the midline, back down to the bottom. So that's why that midline is so important, because that tells us we have to start or where we are adjusting from. Where is the amplitude being taken from? From the midline. 2 units below and 2 units above. Okay, now we're ready to graph. I'm going to graph 2 full periods, and I'm going to label. So this is pi over 6, pi over 3, pi over 2, 2 pi over 3, and we'll forego the units here. We'll just make tick marks to remind me where to stop. Okay, we're starting down at -3. We're going up to the midline, up to the top at 1, back down to the midline, down to the bottom. There's 1 complete cycle. 1 more period. We're starting at the bottom. We go up to the midline, up to the maximum, back down to the midline, back down to the bottom, and nice smooth curve, right? We don't make sharp points here. Nice smooth curve, very cyclic, very much like an ocean wave. And that's what we do. That's our very first one. Not so bad, right? It's a lot to take in, I know, but you can do it. I believe in you. One thing I didn't really talk about here is the domain and range of these functions. We can kind of look at it. Domain should always be all reals. There should never be restrictions on our domain. The range, what do you see the range going from? I mean, it's in the table that we created. Here's the minimum, here's the maximum. So the range would be from -3 to +1. Okay, in our next example, we have 2 times sine of x over 3 plus 4. Let's label A, B, C, and D. A is 2. B is 1/3, right? We're going to pull x out of it. C is 0, and D is 4. The amplitude is given by the absolute value of A. The absolute value of 2 is 2. The period is given by 2 pi over b. This would be 2 pi over 1/3. That would be 2 pi times 3. That would be 6 pi. The phase shift, since c is 0, we don't have to worry about that. And the equation of the midline is going to be y equals positive 4. Uh-oh. I don't think my graph is suited for this problem, is it? Oh well, we'll make do with what we have. Okay, so let's see. A is positive, so we're starting, well, this is sine, so we start in the middle, then we go up to the top. What else? We want to figure out the increments as we fill in this table. So the increments will be given by the period, which is 6 pi divided by 4. 6 pi divided by 4 is 3 pi over 2. So we have x and f of x. I'm going to fill in my x values first. We're starting at 0, and we're adding 3 pi over 2. So 0 plus 3 pi over 2 is 3 pi over 2. 3 pi over 2 plus 3 pi over 2 is 6 pi over 2. 6 pi over 2 is the same as 3 pi. Now we're going to think about this as 6 pi over 2 because we're adding something with a 2 in the denominator. So 6 pi over 2 plus 3 pi over 2 is 9 pi over 2. And then lastly, 9 pi over 2 plus 3 pi over 2 is 12 pi over 2, which we affectionately call 6 pi. Do we feel good about 6 pi? We should. It matches our period. Hooray! Okay, so now, whoa, what's going on here? The equation of the midline. So the middle of this, you know what, I can kind of cheat here just so I can fit it on my graph. I can count my y's by 2's. So that's going to allow me to squeeze all of this onto the graph. Starting, the midline's at 4, so the midline's there. And we always start with our sine graph at the midline. So we're starting at 4. Then we go up. We're going to go up the value of the amplitude. So it's going to be 4 plus 2. We're going up to 6. We go back to the middle. We go down. We're going down 2, right? It's going to be the middle minus the amplitude. 4 minus 2 is 2. Back to the midline at 4. All right, I'm going to label my x. We have 3 pi over 2 and 3 pi. Here we have 9 pi over 2. Here we have 6 pi. And I'm going to want another cycle, so I'm just going to add 4 more. And you might know that this should be 12 pi. And if you didn't know that, that's okay too. Now we're going to graph these points. So 0, 4 is up here. 3 pi over 2, 6, we're going up. At 3 pi, we're going back to the middle. At 9 pi over 2, we're going down to the minimum. 6 pi, we're going back to the middle. There's our first period. Second period starting at 6 pi, we're going up to the top, back to the middle, down to the bottom, back to the middle. Nice smooth curve here. Nice smooth sine curve. There would be 2 periods of this particular function. And as always, if you're freaking out about this, first take a deep breath. Ready? Second, you can always fall back on your calculator if you need to. Now, I'd rather you not have to use your calculator. I'm certainly not using my calculator, but I'd rather you use your calculator than not do anything at all. So if worse comes to worse, plug in 0 into your calculator, see what happens. You will want to know the period and you will want to know the increments, so that way you know what to plug in so you can get your corresponding y values. Okay, 2 more examples. This is sine. Sine starts in the middle. And let's figure out A is 1/2. And B is 2. C is pi over 6. And D is 0. The amplitude here is the absolute value of 1/2, which is 1/2. The period is 2 pi divided by the B, which is 2. So our period here is pi. The phase shift. So this is C over B. We actually have a C value. C over B is going to be pi over 6 over, where's B? 2. So that's going to give us, yikes, pi over 6. Dividing by 2 is the equivalent of multiplying by 1/2. Our phase shift here is pi over 12. What we might want to do is we might want to figure out, that's our starting point is pi over 12. What's the end point going to be? And I like figuring out the end point because we get to double check with the increments too. So remember the end point here is we take the phase shift, pi over 12, and we add 1 full period to it. So we're going to add pi to it. 1 pi, or pi over 1 is equivalent to 12 pi over 12. So our end point should be 13 pi over 12. So the end of the first cycle right here should be 13 pi over 12, and we're going to confirm it when we determine the increments. The equation of the midline here will be y is equal to d, which is 0. So it's just that positive x-axis or negative x-axis, just the x-axis. Okay, let's look at our 5 key points here. Now that we have our phase shift, so remember what the phase shift tells us, we're now starting at pi over 12. Our increments are we still calculate those the same way. So to figure out the increments, we take the period. What was the period? The period was pi, and we divide it by 4. So we're adding pi over 4s, and this is going to be a lot of adding of fractions. Remember, when we add fractions, we need common denominators. Pi over 12 plus pi over 4, we need a common denominator. I'm going to use 12. Pi over 4 is going to be the same as 3 pi over 12. Pi over 12 plus 3 pi over 12 is 4 pi over 12, which I'm going to simplify to pi over 3. And you should talk to your instructor if you actually need to simplify. I'm sure if you're using a homework system, you're going to have to. But for me, this is like the one time in life that I say it's okay to not simplify, because this is hard enough and you don't need the extra additional challenge, but I will simplify. You don't have to. Okay, so now I'm going to use my unsimplified 4 pi over 12. No, why would I do that? Yeah, I'm going to do that and add pi over 4 to it. Now I'm going to use, it didn't really matter if I stuck with the pi over 3 since these aren't the same denominator anyway. But that's okay. Okay, so now we have 12 and 4, so we're going to multiply again by 3 pi over 12. 4 pi over 12 plus 3 pi over 12 is 7 pi over 12. Now I'm going to take 7 pi over 12, and I'm going to add to it pi over 4. Pi over 4 is the same as what? 3 pi over 12. So 7 pi over 12 plus 3 pi over 12 is 10 pi over 12. And let's verify that we do end up with 13 pi over 12. 10 pi over 12 plus pi over 4, which is equivalent to 3 pi over 12, is 13 pi over 12. Hooray! It worked out, so I feel good. I feel like I did something right. Such a good feeling. Great. Okay. I don't know why I put a half in here. That was clever. Let's fill in the y values. So this graph should start at 0. We're starting at the midline. We're starting at 0. The amplitude is a half and it's positive, so we're going to go up to the maximum. We're going to add a half. We're going back to the midline. We're going down to the lowest point, which will be at negative a half, and back to the midline. All right, let's look at the graph. So here we have pi over 12. Here we have pi over 3. Here we have 7 pi over 12, 10 pi over 12, and 13 pi over 12. Then we're going to do 1, 2, 3, 4 more for the second period. I'm going to do my cheaty thing where I'm going to say here's 1, so this is a half, this is negative a half, and negative 1. All right, let's go. We're starting at pi over 12. Pi over 12, 0 is right here. At pi over 3, we're going up to a half. At 7 pi over 12, we're going back to the middle. 10 pi over 12, we're going down to the bottom to negative a half, back to the middle. One more period, go up to the top, back to the middle, down to the bottom, and back at the middle for our sine graph. We're starting here. It's weird not starting at 0. Out of habit, I want to start at 0. And there we have 2 full periods of a function with a horizontal shift. Okay, in our final example, we're putting everything out on the table. We have changes everywhere. Let's lay out what we have. We have a is equal to negative 3. B is equal to a half. C is equal to negative pi over 6. And D is equal to negative 1. This is a sine graph, so we should be starting in the middle. And we will start in the middle. But let's label all of our information. The amplitude, that's found by taking the absolute value of a. So that's going to be the absolute value of negative 3, which is 3. The period is found by taking 2 pi and dividing it by b. So that's 2 pi over a half. That's going to give us 4 pi. The phase shift is found by taking c over b. So that will be negative pi over 6 over 1/2, which we can rewrite as negative pi over 6 times 2 over 1. We can multiply by its reciprocal, and we're going to end up with negative pi over 3. the equation of the midline, that's y equals d, so we'll have y equals -1. What other information do we want? We might want to know the ending point, or the ending x coordinate of the first period. So the first period is going to start here at -π/3. We figure out that end point, so end point of one single period is going to be the phase shift, -π/3, plus the period, plus 4π. -π/3 plus 4π, that would be 4π/1. If we're going to add our fractions, we need a common denominator, so we'll use 3. We're going to end up with 11π/3. And we'll verify that in just a minute. Something else to take note of is that a is negative. So whereas the parent function sine graph starts in the middle, goes up, down, back to the middle, down to the bottom, back to the middle. What this one's going to do, it's not going to look like this because of that negative. It's going to start in the middle, go down, back to the middle, up to the top, back to the middle. Okay, so what we're going to do is we're going to label this x and y. This is going to start at the phase shift, so it's shifting over -π/3 units. And then from there, we're going to add, oh, we haven't figured that out yet. So what are the increments? We need to do that calculation. The increments will be, how do we determine the increments? Take the period and divide it by 4. 4π divided by 4 will be pi. So our increments are pi's. So we're going to start here and we're going to add pi. -π/3 plus 1π. Well, what's 1π in terms of thirds? That would be 3π/3. So -1π plus 3π is 2π/3. Okay, then we're going to take 2π/3 and we're going to add pi onto it. So that would be 2π/3. And remember what 1π was equal to? It was equal to 3π/3. 2π/3 plus 3π/3 is 5π/3. All right, let's find our next one. So it's going to be 5π/3 plus, and remember it's going to be 3π/3 again, and we get 8π/3. And last but not least, this is what we're expecting. 8π/3 plus 3π/3 does in fact equal 11π/3. So you can feel really good that these match up. You've done something right. Yay! How about our y values? So let's look at our midline. Our midline's right here. Boop. So we're starting the middle point, or the middle of this graph will be at -1. This is a sine graph, so we're going to start at that middle at -1. From here, we're going to use the amplitude to help us find the next y coordinate. So it's negative, which means we're going to start by going down, and we're going down 3 units from -1. So what's 3 units down from -1? That'd be -1 minus 3, which is -4. So we're going to go down to -4, go back to the middle. Now we're going to go 3 units to our maximum. It's going to be -1 plus 3 gives us 2. And then we go back to the middle. Okay, for this, I think we're going to count. I don't know if I'm going to be able to fit 2 full periods on here. We'll see what we can do. But I'm going to count by π/3s. And I do need to start a -1 over here. So this is going to be -π/3. This will be 0π/3, 1π/3. Here's 2π/3, 3π, 4π, 5π/3, 6π, 7π, 8π/3, 9π, 10π, 11π/3. So I'm only going to be able to fit 1 period on this graph. So whoop, include 1 full period because we ran out. Sorry. All right. So we're going to start at -π/3, -1. We're going down to -4. Oh, I don't know why I'm going to 0. Let's try that again. Go over to 2π/3 and go down to -4. There we go. 5π/3, we're going up back to -1. At 8π/3, we're going up to 2. And 11π/3, we're going back to the middle. So a nice smooth curve here. We start by going down, which confirms that negative in front of the sign itself. And there would be 1 full period. We could fit a second period if I had changed the increments, but I'm pretty happy with what I chose, so I'm going to stick with that. These have been examples of looking at all sorts of transformations on sine and cosine graphs. Thank you for stopping by.